Hello my esteemed viewers. In this tutorial we will present miscellaneous problems that are iterative in nature and we will see a mixed use of for, while and do while loops and we have presented umpteen number of problems here in this tutorial. So we will move with the first example. The first example is about accepting a number n, say 4 or 5, something like that. Then it finds the sum of the integers from 1 to 2, then from 1 to 3, then from 1 to 4 and so on, and then from 1 to n. Therefore, it generates the terms depending upon the last term. So if we choose the last term to be 5, it generates something like this. The first term will be 1, the second term will be 1 plus 2, the third term will be 1 plus 2 plus 3, the fourth is 1 plus 2 plus 3 plus 4, that it becomes 10, and 1 plus 2 plus 3 plus 4 plus 5, it becomes 15. So that's how. This problem immediately tells us that it needs two for loops, one inside the other. The outer for loop probably sending the first term, second term, third term, fourth term, fifth term. If number of terms asked by the user is 5, then outer for loop should work for 5 number of times, and the inner for loop is meant for generating the term values. So for example, when the outer for loop is in the second cycle, the inner for loop will generate 1 plus 2 plus 3, something like this. Okay, and we will go through this program to understand as to how this simply works. Integer, these are all the variables that are set forth. Integer I and j exclusively for running for loop as loop indices. Sum is the sum. The sum is nothing but the term, the term value, and n is the number of terms that is given by the user. Enter an integer. Okay, in spite of this, instead of this, we should have written enter the number of terms you want. Okay, that would be the better option. Okay, and we will change it here only. Enter the number of terms that is needed. Okay, better than number of terms. Okay, number of terms needed. This is better. And this is more appropriate also. Let us say user enters n. That means if user enters n equal to 5, then he needs 5 terms to be generated. So therefore outer for loop is set forth in order to send the first term, second term and third term. Okay, it invokes the term proper. So I is equal to 1 up to n, less than or equal to n, I plus plus. So in the first cycle of the outer for loop, I is equal to 1. In the second cycle it will be 2, 3, 4, 5 like this up to n. Sum equal to 0 here. So inside the outer for loop, sum is always set to 0 because every term is new and every term is to be generated. For example, the second term is to be generated by adding the first term, first value 1, 2, 3, something like this. Therefore it has to go like this. So sum should be initialized to 0 for every new term that is generated. For j equal to 1, j less than or equal to I, j plus plus. So here in the first iteration of the outer for loop, j equal to 1 and j less than or equal to I will bring 1. Therefore, it is sum plus equal to j. That is sum, earlier value of sum is 0, 0 plus 1 equal to 1. So sum will be generated. Once again, the sum will become 0. Then it will go for the second iteration when I would have become 2. Therefore, it is sum plus j, sum equal to 1 plus 2, that will become 3. Then in the third iteration, sum is set to 0, it will become 1 plus 2 plus 3, something like this. It goes on adding and it will generate only the term value for 5 number of terms if the input is 5 or whatever the input is given by the user. Now, the second example is a famous example that is about generating, computing the value of sine of an angle. And our respected viewers should understand that sine of an angle can be generated by just evaluating this particular series. As before, the sign of an angle will be more accurate if you consider more number of terms. Of course, we have two methods to tackle this problem. Either we can predicate the number of terms that you want to exercise or that you want to compute, let us say 10 terms or 15 terms or whatever. Anyway, the equation is more number of terms, more accurate the value of sign of angle is, or we can restrict the accuracy. Okay, the restriction of the accuracy has been very well explained in our previous tutorial while we computed the value of pi. So therefore, this problem is tackled by both the methods. One, by predicating the number of terms. Two, by predicating the accuracy. And here it goes. And one should be very careful in formulating the program for this or coding this particular series. And series has to generate alternate terms which are positive and negative. Okay, terms are positive and negative alternatively, like a sinusoidal wave, and this is a second term is x cube and x to the power of 5, x to the power of 6. Numerator is to be generated and denominator is also to be generated. As far as denominator is concerned, it is an odd factorial. As far as numerator is concerned, it is an odd power of radian value of an angle. Here sine of an angle expressed in radians, because computers will never understand if you give the angular value. Therefore, we will, with this knowledge, we will just jump into this program and let us try to understand this. Okay, here is a ready-made program that is available. Float x. X means the angle. Sum means to sum up the series. Okay, the answer is contained in this particular sum. Term is the individual term. Therefore, term will involve the angle value raised to odd power divided by odd factorial, depending on the number of terms. If it is a third term, the numerator will be x to the power of 5 and the denominator will be 5 factorial. And here these particular variables, one integer I to run the loop, option, okay, whether the user selects the accuracy value or the other thing, or number of terms, nt number of terms, and j, it is also meant for the loop. And we go like this, enter the number of terms. Okay, let us say I will enter 10 and you will enter 10. Okay, that means to say we need to go computing the value of sine of an angle up to 10 terms. And the loop starts over here because we need to find out 5 angles. Okay, sine of angles which are 5 in number. Let us say 30, 45, 90, 60 and 0, something like that. Enter the angle number. Okay, as soon as the execution starts, it will come enter the angle number 1. So user will be directed to enter the angle. So 1 will be portrayed over here. The user will enter, let us say he will enter 30 degree, then 30 degree will be immediately converted into radian value. So x entered in degrees will become the same x converted into radians. And this kind of expressions are really feasible in C programming. See, x here, when it is taken inside the computer, it is value of an angle in degrees. When it is converted, gets converted into radians, x will remain to be radian. And sum equal to x, because the first term is x. First term will never start with 0, or first term will never start with 1. If that case be, then we would have indicated we would have initialized sum to be equal to 0 or sum to be equal to 1. Therefore, here sum to be equal to x and term is also equal to x. Okay, then it will go inside. Now for j equal to 1, j less than or equal to number of terms, j plus plus. It is actually this for loop which will compute the angle, given angle, the very first angle, let us say 30 degree. Now term will become minus term. Okay, term is already x over here, minus x into x into x, that is x cube minus x cube divided by 2 into j, j is 1, 2 into j, it is 2 into j, that is 2 into 2 plus 1, that is 3, 2 into 3. So this would amount to 3 factorial. Okay, sum equal to sum plus term. The earlier value of sum is x, therefore plus term value is minus x cube divided by 3 factorial. So sum that we have accrued is sum plus the earlier sum plus the term value. Once again in the second cycle, j will become 2 and this will become, term is already minus, okay, it is minus into minus term, it will become plus term, that is term is already x cube. In the earlier iteration it was x cube, now it is x cube into x, it becomes x to the power of 5 divided by 2 into 2, because we are going for the second iteration, 2 into 2, j will bring with it 2, the value equal to 2, 2 into 2 is 4, 4 into 4 plus 1, that is 5. So earlier term contains x cube by 2 factorial, that is 2 into x cube by 3 factorial. Now it becomes x to the power of 5 by factorial by multiplying the earlier term with a negative sign. So this is how we generate alternative positive and negative terms. Okay. Now at the end we will print sign of the angle, that is percentage of sum. Okay, sum will contain the answer. Close the outer for loop. So now this for loop will end only upon computing sine 5 angles and its sine values. Okay, we will go for the next kind of a problem. It is once again same sine of an angle, but here we dictate a particular level of accuracy. Okay, the sine of that angle for the given level of accuracy, it also calculates the value from library function. Since library function is involved in this program, math h is included. And you should have included conio.h also, because if you want to put get ch somewhere in order to hold the answer for a while on the screen, and you should necessarily place get ch, therefore you should necessarily include since there is a get ch, okay, or what is called as conio.h. I will just make it to include. Okay, so hash include, okay, lesser than symbol conio console input output dot h. Okay, this will dictate as to how get ch should work. Okay, nothing to worry furthermore. So float x, once again angle in radians. First of all it will be taken in degrees. Sum, it will contain the answer. Term, the independent term, individual term. Accuracy, the level of accuracy predicated by the user, and these are all the integer values meant for number of terms, and option and j, etc., etc. Okay, this program is exactly written in order to make a menu driven program, therefore option surfaces over here. Anyway, the example quoted over here sans that particular menu driven activity, therefore I suggest my respected viewers to develop the program in such a way that it is menu driven, where you can make use of this option. Option will take from the user whether he or she wants to compute the sine of an angle by considering number of terms or by considering the level of accuracy. Here this problem is very specific. It addresses the accuracy. Okay, it fixes the number of terms by fixing the level of accuracy. Okay, enter the accuracy level. Let us say user may give 0.00001. Okay, so that will be taken inside. It's a typical float value. Now you should recall as you go for number of terms increasingly in the sine series, okay, it becomes marginal. The value it brings out is really marginal. For example, if sine 30 we want to evaluate, sine 30 when it is converted into a radians, it will become a very small value. When this small value is raised to the power 7, it becomes still small. And once again it is divided by 7 factorial, it will become still small. Okay, it happens only, let us say, after the 7th term or after the 5th term. Anyway, the value that is brought out or evaluated in a particular term, in a single term, is will happen to be very meager. At a particular point in time, at a particular term level, it may go to a level which is lesser than accuracy. Okay, and if you go for the next term, it will be adding this accuracy. If you go for the other next term, it will be subtracting the level of accuracy. Therefore, we will hold the value of the term itself to the accuracy level. Okay, and we will compare the accuracy with the absolute value of the term. Okay, absolute value of the term. That's how we fix the accuracy, and we never take the value of sine of an angle up till here and then we will minus it out with the value of the sine of an angle in the previous term obtained, because it is alternatively positive and negative. Okay, that is a simple reason why we hold the term value itself as the accuracy level. Okay, now we are here, accuracy is right. Enter the angle number, because here also you are going to compute for 5 different angles. Okay, this for loop is meant. We know we want to calculate only 5 different angles, therefore for loop is the candidate. It will start from 1, it will go up to 5. 1, 2, 3, 4, 5. 5, exactly 5 number of cycles. As far as the other computation is concerned, we don't know when exactly accuracy is met with. Therefore, we will make use of do-while loop. So this is a best example to illustrate that the usage of for loop and do-while loop should go hand in hand. Okay, scanf, the angle is entered, it will be converted into radians by multiplying pi by 180. We could have written pi by 180, 3.141, etc. But anyway, we will leave the points to the computer itself. Instead of writing pi, we will write 22.0 divided by 7. Okay. Anyway, computers are traditionally accurate up to 6 decimal points. Therefore, our computation will happen to be still more accurate. Okay. Instead of considering 3.141, we are considering pi directly as 22.0 divided by 7. Sum equal to x as previously, term equal to x, j equal to 1. Okay, it will enter into the first cycle, do, term equal to minus term x into x. Term is carrying x, so minus x into x into x, it becomes minus x cube divided by 2 into 1 into 2 into 1 plus 1, that is, it is 3. So 2 into 3, this becomes 3 factorial. So term will contain minus x cube divided by 3 factorial. So sum will become earlier sum is x minus x cube by 3 factorial. Now when j becomes 2, j value will become 2, then term will become the earlier term was minus x cube by 3 factorial. Minus into minus, it will become plus. It becomes x cube into x, that is x to the power of 5 divided by 3 factorial is already there. 3 into 2, 3 factorial means 3 into 2. Here 2 into 2, because j will become 2. Okay, 2 into 2, that is 4, and 4 plus 1, that is 5. So 4 into 5. Okay, 2 into 3 into 4 into 5. So that gives you 5 factorial. And sum will be added over here. That's how cyclically it generated. And this while loop works as long as the absolute value of the term, it is FABS because the term is typically float in nature, because it is float in nature, where x value is in radians, which is also a float value. Okay, therefore FABS is used. It is wrong to use ABS. Okay, FABS absolute, because it is one time it is negative, one time it is positive. Anyway it is the term value which is bringing the value, which is adding or negating at a point of time for a particular term, and this value will essentially become somewhere in the series, okay, lesser than accuracy level. Okay, anyway, this while loop has to work as long as the absolute value of the term is greater than accuracy. So whenever it becomes lesser than or equal to accuracy, it will break up and come out only to print the value of sine of an angle. Okay, now we have just printed the screenshot of the output. Okay, this is a menu driven program. Anyway, you have chosen designating the accuracy. I told you, I requested my respected viewers to build a program which is menu driven. Okay, enter your option, that is 2, by designating the accuracy. Enter the accuracy level. User has given 0.00001, that is 1 into 10 to the power of 6 minus 6. You could have given 1 e minus 6 in place of printing like this. Okay, enter the angle number 1. Okay, it is 30 degree. Sine of the angle is 0.500183. Look at this answer. It is accurate up to 6 decimal places. Enter the angle number 2. It is 60 degree. Sine of the angle is 0.866236. And enter the angle number 3, that is 45. Okay, everything is printed, and this program goes by fixing the level of accuracy. Right. Similarly, in the same token, we have come out with the program for cosine of an angle by inputting an angle in degrees to a given accuracy. And cosine series goes like this: 1 minus x. It has alternative positive and negative terms once again like sine series, but anyway it is even terms. X square by 2 factorial, x to the power of 4 by factorial, minus x to the power of 6 factorial. So we find a trick to generate both the factorial as well as the power. Okay, the even power of the angle. Float x, term, sum, fact, accuracy, I, all these things are mentioned. Printf, enter the accuracy. User will be giving the accuracy level. For j equal to 1, j less than or equal to 5, because we need to find cosine of 5 angles which are different in nature, So printf, enter the angle number 1, okay, in the first cycle. Fact equal to 2. We initialize the fact value which comes in the denominator as 2. I equal to 2. Sum equal to 1. Okay, because the first term in the cosine series 1. Earlier you may recall, as far as sine series is concerned, the first term happened to be x. Okay, therefore sum was initialized to x there. Printf, enter the angle. The user will enter the angle, let us say 30 degree. It will be converted into its equivalent radian value. Now term will become power of x comma I. Here x is the angle in radians. I means 2, because we have set I to 2. So this will generate x square divided by fact. Fact we have said 2. 2 is nothing but 2 factorial, because 2 into 1 is 2 factorial. Now sum equal to sum minus term. The earlier value of sum is 1. So 1 minus x square by 2 factorial. Now fact will become minus fact. Okay, fact will become minus fact. That is, fact earlier was 2. Now it will become minus 2 into 2 plus 1, that is 3, into 2 plus 2, that is 4. It becomes 4 factorial. So fact will be turning into minus 4 factorial, and I plus equal to 2. I will become equal to I plus 2. Okay, I will become 4. Anyway, when it goes for the next cycle, term will be x to the power of 4 by factorial, x to the power of 6 by 6 factorial. Like this, cyclically the factorial value in the denominator and power value in the numerator will be generated. Okay, you are requested to go through it very coolly and slowly. You will definitely get a grip of this cosine series. Okay, value of the angle from the series is printed, and once again it will be going for the cycle till all the 5 angles inputted by the user will be completed. Okay, enter the accuracy. Everything is calculated over here. Computer. This is a typical screenshot, of course, colored. And this is the last problem, I think. This program examines all the numbers from 1 to 999, displays only Armstrong numbers. Armstrong numbers have a place of sanctity in scientific circles. An Armstrong number is a number which has sum of its own digits equal to the number itself. That means 371 is an Armstrong number, so also 407. What is the significance of them? So 3 cube plus 7 cube plus 1 cube happens to be 27 plus 343 plus 1, 371. Similarly, 407 can be obtained once again by cubing the 4 and cubing this 0 and cubing this 7. It becomes 407 is the original number. When the sum of the cubes of the individual digits equal to the number itself, then that number is an Armstrong number. Okay, it is pretty easy to compute this. Anyway, we need for loop. Okay, we need for loop, and we also need while loop. Okay, we will examine as to why we need for loop, because we need to examine all the numbers available from 1 to 999, and we have to take out those numbers which prove to be Armstrong in nature. Okay, sum equal to 0, because every number is to be delineated with the sum value equal to which sum is new. For example, for 371 sum is new, for 407 sum is new, for 1 sum is new, something like that. And k equal to I, k is set to I, k equal to 1 now in the first cycle, while k not equal to 0, okay, not equal to 0, digit equal to k mod 10, digit equal to k mod 10. Okay, k is I. Okay, k is I once again 2, 3, 4, 5 like this up to 999. K will be filled with cyclically filled with numbers from 1 to 999. Now, while k not equal to 0, let us say the number at a particular point in time, the number is 371. Digit equal to k mod 10. 371 mod 10, 371 mod 10 is 1. Okay, and sum plus equal to, sum is set to 0, sum plus equal to 1 into 1 into 1, 1 cube, and k will be reduced by one digit. 371 will become 37 upon dividing that particular number by 10. It's an integer division, mind you. Integer division will always truncate. Once again it will go till k becomes equal to 0, till the number becomes equal to 0. So anyway, it will generate sum of the cubes of the individual digits, and this is meant for generating the digits, and this is meant for truncating the value. 371 should become 37, 37 should become 3, and 3 is to be cured, something like this. If sum equal to I, if sum happens to be the original number, then it will go for, okay, it will be printed and same plus plus. Okay, right, how many digits are same plus plus, same. Okay, Armstrong numbers, same was set to 0 because we never found out in the beginning of the cyclic procedure, and here same will get 1. Okay, there are only percentage d such numbers from 1 to 999, same. Okay, if there are 4 numbers, it will print as it is. Now from 1 to 999, 1, 153, 370, 371 and 407 are the Armstrong numbers, and there are only 5 such numbers from 1 to 999. This 5 was accrued in same. Okay, next, this is the last problem. The program adds the digits of a given integer till the sum becomes single digits. If the given integer is 1, 2, 3, 4, 4 plus 3 is 7, 7 plus 2 is 9, 9 plus 1 is 10, 1 plus 0 is 1. And 5 plus 4 is 9, 9 plus 3 is 12, 12 plus 2 is 14, 14, 1 plus 4 is 5. Okay, till the sum of the digits of a given number becomes a single digit number, okay, the program gets executed. Now, enter an integer, scanf, you read the number, let us say 1, 2, 3, 4, and you duplicate it because we are going to miss this number. This number is successively slashed, successively we will divide it by 10, and we will also do modular division. Therefore, in the melee, you are going to lose this number. Therefore, we want to store this because at the end we need to write sum of the digits of 1, 2, 3, 4 becomes 1 when it is successively added. Okay, or the single digit sum of 2, 3, 4, 5 becomes equal to 5. In order to write 2, 3, 4, 5 at the end of the program, we have to preserve this number in duplicate number because we are going to lose this, and you will come to know while number divided by 10 not equal to 0, okay. We will do this first anyway. The inner while loop we will do. While number not equal to 0, sum equal to sum plus num mod 10. Okay, if it is 370 or 372, let us say, if it is 372, okay, I will write this anyway. If it is 372, okay, sum is set to 0, 372 mod 10 will give us 2. So sum will get 2, and here in this step 372 divided by 10, 372 divided by 10 will become 37. Okay, so number has not become 0 yet, therefore while loop has to run again. So sum equal to sum plus 37 mod 10. Okay, sum already carried 2 and 37 mod 10 becomes 7, so 2 plus 7 it becomes 9. Then once again, okay, 37 will become Okay, 3, 37 will become 3, and therefore number is not equal to 0. While number means while number not equal to 0. The meaning of while num means while number not equal to 0. That is the meaning. While number, okay, there is a brevity in writing the programs, my dear friends. We should write like this only. Number not equal to 0. While num means if num not equal to 0. Like this. Okay, num not equal to 0. So num has become 3 in the third cycle. It is not equal to 0. Therefore sum equal to, okay, it is already gathered 9. Sum has gathered 9. 9 plus 3, because 3 mod 10 is 3. Once again, if you try to divide num 3 by 10 equal to 0. Therefore number becomes 0. Okay. What you get here is num will be becoming sum. If sum is 12, num will become 12. And this is to be yet again added till it becomes a single digit number. Okay, let us say if the number is 5, 7, 6, 2, if you add them together in this cycle, okay, after the completion of this while loop, what we get is 2 plus 6, that is 8, 8 plus 7 is 15, 15 plus 5 is 20. Okay, num will become 20 because 2 is to be added with 0, and we should get answer to be equal to 2. We will make it 3, then it will become 21. 2 plus 1 equal to 3. So therefore num has not become single digit yet. Therefore num will become equal to 21 over here. And once again here num, okay, it will go over here. Num by 10 not equal to 0. Definitely if it is 21, 21 by 10 is not equal to 0 because it is 2. Then once again same procedure will be adopted. Sum is set to new 0. Okay, sum is set to 0 once again because we need to get 2 plus 1. This is totally a different value of the sum that we are going to obtain. Okay, in the first cycle runs, it is this sum that we are going to get, and I will once again repeat. Let us say it is 2, 3, 4, 5. Okay, if you let in 2, 3, 4, 5 here, sum is set to 0, and while num not equal to 0, then what you get is at this point of time, okay, repeatedly what you get is 5 plus 4 is 9, 9 plus 3 is 12, 12 plus 2 is 14. So once again number will become equal to 14 because it is not single digit number, and here it will go to this, and this while loop will question while number divided by 10, that is 14 divided by 10 not equal to 0. Yes, it is sure because 14 divided by 10 equal to 1. Okay, now sum equal to 0, and once again the same thing repeats. While 14 not equal to 0, sum equal to 0 plus, okay, 14 mod 10, that is 4, and num by 10, okay, num equal to num by 10. Okay, num by 10 is 14 by 10. 14 by 10 is 1. Once again num mod 10 not equal to 0. Yeah, it is not equal to 0. 1 mod 10 is not equal to 0. Once again it will go and it will compute, and finally we will get the answer, okay, which is a single digit answer, right? Right. I think we will end up with this tutorial session all kind of problems put together from the tutorial number 1 when I started discussing on iterative constructs. I think we have covered not less than 25 to 30 programs. So I request all my respected viewers to go through again and consolidate your idea in building programs which are iterative in nature, which are totally iterative in nature. Next we will take on to arrays. In arrays, while we do computation with arrays, once again these iterative constructs will become part and parcel of the array manipulation techniques. So until then, bye and thank you.